Hello and welcome to Algebra 1, Lesson 12. In this video, we're going to continue learning about how to solve linear inequalities in one variable. So we're just going to kind of jump in here. We already know the basics, and so anything else that we're going to learn along the way. So when I look at this, I have negative 4 times the quantity x minus 4 is greater than or equal to negative 2 times the quantity x plus 1. Now, the same way I would do an equation, I'm going to simplify each side completely. So I'm going to use my distributive property on the left. Negative 4 times x is negative 4x. Then I have negative 4 times negative 4, that's plus 16. And this is greater than or equal to. We have negative 2 times x, that's negative 2x. And then negative 2 times 1, that's minus 2. Now, just like with an equation, I want all my variable terms on one side of the inequality and all my numbers on the other. So I can use my addition property of inequality to accomplish this. I can add 2x to both sides of the inequality. This will cancel. And let's see what we have. We have negative 4x plus 2x, that's negative 2x. So then plus 16 is greater than or equal to negative 2. So now I just want to subtract 16 away from both sides of the inequality. So this can go away and my variable term is isolated. All right, so now on the left, I just have negative 2x, and then is greater than or equal to. On the right, negative 2 minus 16 is negative 18. And I have one final step. I just want to isolate my variable x, and so I'm going to divide both sides of the inequality by negative 2. But remember, we talked about this in the last lesson. If you multiply or you divide by a negative, you've got to flip the direction of the inequality. So right now, this is a greater than or equal to. We're going to make it a less than or equal to, again, because we divided by a negative. All right, so once we've flipped it, we don't have to do anything else. This cancels with this, and we just have x. And then on the right, negative 18 divided by negative 2 is 9. So our solution here is x is less than or equal to 9. Now, one thing we want to do when we're working with inequalities, we want to write our solution in what's known as interval notation. So we spent a lot of time on that in the last lesson. And so if you haven't covered that yet, I want you to go back to the last lesson and learn how to do that. So if we have x is less than or equal to 9 in interval notation, remember, it's less than or equal to 9. So the smallest value, there won't be one, right? Because x could be 9 or anything less than that. So we're going to use negative infinity in that position. And remember, when we use positive infinity or negative infinity, we always put a parenthesis next to that. And then for the largest value, we're going to use 9. Now, 9 is included in our solution. And when something's included, we're going to use a bracket, right? Not a parenthesis. So we have our solution in interval notation. And then we just want to go ahead and graph it. So we're going to locate 9 on our number line. And 9 is right here. And I want to put a bracket at 9 that's facing to the left. It's always going to be facing in the direction of the solution. So the bracket goes there. And then I'm just going to shade everything to the left. Everything to the left. Shade all of that, including the arrow. So x could be 9. That's why the bracket's there. Or anything to the left of 9 on the number line. All right, let's take a look at another one. We have the opposite of the quantity, r plus 3. And this is less than or equal to negative 3 times the quantity, r minus 1, and then minus r. So I'm going to use my distributive property here. I'm going to distribute this negative to each term. And remember, you could put that as plus negative 1. And think about that as, okay, I'm multiplying negative 1 times r, that's negative r. And then negative 1 times 3, that's minus 3. You can also just change the sign of each term inside the parentheses. That will allow you to remove the parentheses. Remember, if I see just a negative out in front of parentheses, in order to remove the parentheses, I change the sign of each term inside. So negative r minus 3 is less than or equal to, negative 3 times r is negative 3r, and then negative 3 times negative 1 is plus 3, and then minus r. All right, so let's continue simplifying. On the left, I have negative r minus 3, and this is less than or equal to. On the right, I have negative 3r minus r. I can combine those like terms. That'll give me negative 4r, and then plus 3. And now I want to move all the variable terms to one side and have the numbers on the other. So what I'm going to do is I'm going to add 4r to both sides of the inequality. So this is going to go away. And negative r plus 4r would be 3r. So then minus 3 is less than or equal to 3. And now I'm simply going to add 3 to both sides of the inequality so that I can isolate this 3r. So this will go away. And on the left, I'll just simply have 3r now. And this is less than or equal to 3 plus 3 is 6. Now as a final step, I'm going to divide both sides of the inequality by 3, which is the coefficient of r. Now again, because I'm dividing by a positive number, I don't need to do anything with the sign. It's only if I'm doing it with a negative number. So this will cancel with this. I'll have r, and then is less than or equal to 6 divided by 3 is 2. So r is less than or equal to 2. All right, so in interval notation, again, we have r is less than or equal to 2. So that's going to look like this. We'd have negative infinity right here. We'll put a parenthesis there to say that negative infinity is not included. And then this is up to and including 2. Right? So we're going to use a bracket at 2. Because r can be anything kind of starting out at 2, including 2, anything moving to the left. So the smallest possible value, there's not one. That's why we put negative infinity here. The largest possible value is 2, and 2 is included, so we put our bracket. Now again, when we graph this, we put a bracket at 2, facing to the left. It's facing towards the solution. And then we're going to highlight, or we're going to shade everything to the left, including this arrow, to say, hey, 2 is included, and everything to the left of 2 is included as a solution as well. All right, let's take a look at another one. We have negative 8/5 minus x is greater than negative 1/4 x minus 11/5. So just like if we had an equation with fractions, if we have an inequality with fractions, we can go ahead and multiply both sides of the inequality by the LCD. So the LCD here would be 20, right? 5 times 4. So I can multiply 20 times the left side, which is negative 8/5 minus x. Remember to use brackets or parentheses, right? You got to multiply 20 by both terms. This is greater than, I'm going to use brackets over here, negative 1/4 times x minus 11/5. We're multiplying everything over here by 20 as well. So 20 times negative 8/5, 20 would cancel with 5 and give me 4. 4 times negative 8 is negative 32. So then minus 20 times x is 20x. And this is greater than, over here, 20 times negative 1/4 x. So 20 divided by 4 is 5. 5 times negative 1 is negative 5. So this would be negative 5x. And then minus 20 divided by 5 would be 4. 4 times 11 is 44. All right, so I want to get my variable term on one side of the inequality and a number on the other. So I'm going to add 5x to both sides of the inequality. That's going to go away. And on the left side, I'm going to have negative 32. Negative 20x plus 5x is minus 15x. This is greater than negative 44. So then the next step is to add 32 to both sides of the inequality. So that'll cancel. And I'll have negative 15x is greater than negative 44 plus 32 is negative 12. And as a final step, I'm going to divide both sides of the inequality by negative 15, which is the coefficient of x. Again, when I divide by a negative, and I'm working with inequalities, I've got to flip the direction of the inequality. So this is going to get flipped. Right now it's a greater than, we're going to make it a less than. So this would be that x, right, because these are going to cancel, is less than negative 12 over negative 15, that's positive. Really think about 12 as 4 times 3, and 15 as 5 times 3. So the GCF would be 3. Cancel that between numerator and denominator, and you're going to get 4/5. So we'd have x is less than 4/5. All right, so let's write this in interval notation. So since x is less than 4/5, really for the smallest value, we're going to put negative infinity, right? Because this is going to keep going forever and ever and ever in the left direction. So we'll put a parenthesis next to that. And then for the largest number, we're going to put 4/5. And remember, that's not included because we have a strict inequality. So we're going to use a parenthesis there as well. Now graphically, we don't have a notch for 4/5, but let's say it's somewhere right there. Let's say this is 4/5. I'll put the notch there. And so I'm going to use a parenthesis at 4/5. It's going to face to the left. And I'm going to shade everything to the left, including this arrow right here. So that would be x is less than 4/5. All right, let's take a look at another one with some fractions. We have 33/10 minus 1/5 x is less than negative 1/2 x plus 1 minus 2x. So the first thing I'm kind of looking at here is, to clear the fractions, the LCD is 10. All right, I have 5, I have 2, and I have 10. 5 times 2 is 10, so the LCD is 10. So let's multiply both sides of the inequality by 10. So I'd have 10 times, remember to use brackets, or again, you could use parentheses if you want. So 33 over 10 minus 1/5 times x, close the brackets, and then this is less than, open brackets, negative 1/2 times x plus 1 minus 2x, close your brackets, and this is multiplied by 10 as well. So 10 times 33 over 10, the 10s would cancel and you just have 33. Then minus 10 times 1/5. 10 divided by 5 is 2. So then 2 times 1 is 2, then times x, so you just have minus 2x. And this is less than. Over here, we have 10 times negative 1/2 x. So the 10 would cancel with the 2 and give me a 5. 5 times negative 1 is negative 5. And then don't forget the x. So negative 5x there. Then plus 10 times 1 is 10. Then minus 10 times 2x is 20x. So I can combine like terms on the right side here. Negative 5x minus 20x is minus 25x. So I'll put negative 25x plus 10. So over here, nothing to combine. I'm just going to write negative 2x out in front plus 33. And now I want to get a variable term on one side of the inequality and a number on the other. So in order to do that, I'm going to add 25x to both sides of the inequality. That's gone. And negative 2x plus 25x would be 23x. So then plus 33 is less than 10. I'm going to move this over here. I'm going to simply subtract 33 from both sides of the inequality. So this is gone. And I'm going to end up with 23x is less than 10 minus 33 is negative 23. So as a final step, I'm going to divide both sides of the inequality by 23, which is the coefficient of x. So divide this by 23 and this by 23, and I'm going to get x is less than negative 1. All right, so in interval notation, again, the smallest possible value, if you're dealing with a less than, it's less than negative 1, so this would continue to the left forever and ever and ever. So we write negative infinity here, and we always use a parenthesis with infinity or negative infinity. And then comma, for the largest possible value, we put negative 1. And again, that's not included, so we put a parenthesis there to show that. Now graphically, I'm just going to put a parenthesis at negative 1, facing to the left, facing towards the solution. And then I'm going to shade everything to the left, including that arrow, to say, hey, negative 1's not included, so I got the parenthesis there, but everything to the left of that would be. So another thing we're going to come across will be three-part inequalities. So you see here we have 5 is less than x and x is less than 7. Or you could say x is greater than 5 and x is less than 7. What's important to note here is that both conditions have to be true. So in other words, you can kind of think of these as separate problems. I can kind of think of this as x is greater than 5. So if I was to graph that, x is greater than 5, I would think about what? I would think about putting a parenthesis here, and I would graph everything to the right of 5. And then for the other part of this problem, x is less than 7. So x is less than 7. Now if I graphed that, I would put a parenthesis at 7, and I would graph everything to the left. Everything to the left. Now, when we have a three-part inequality, we're kind of combining the two and saying, hey, I only want the section that solves both. So if we look at what's shaded by both, and it's kind of hard to tell, but it's going to be this area between 5 and 7. 5's not included, and 7's not included. but anything between those two would be included. If you think about it, it should make sense to you. Let me kind of erase this. X can be any number that satisfies both conditions. So if I plug in something between 5 and 7 like 6, 6 is greater than 5 and 6 is also less than 7. So that works out. If I plug in something that is outside of the solution region for one of them, let's say I plug in x is 0. Well, 0 is not greater than 5. It's less than 7, but it's not greater than 5. So it doesn't satisfy the inequality because one part fails and it's got to be a solution to both. All right, so let's graph this again from scratch. You're going to start out at your smallest value, and in this case, it's going to be us starting at 5 with a parenthesis because 5 is not included. And then we're going to look at our largest value, and that's going to be us going to 7 and putting a parenthesis because 7 is not included. And we shade all the area between. All the area between. So anywhere in there is a solution. I know we think about 6 because it's a nice, neat whole number, but really anything between 5 and 7. So 5.122228 would be a solution, right? Because that's larger than 5 and less than 7. Now, in interval notation, it kind of follows a similar pattern. For our smallest number, we'd put 5 and a parenthesis next to it to say 5 is not included. Then comma, we'd put 7 for the largest and a parenthesis to say 7 is not included. So this is your interval notation, and here is your graph. So to solve a three-part inequality is no more difficult than solving a regular inequality. Now, you can do it two ways. And the most popular way, the easiest way, is kind of to do the same thing to each part. So let me kind of show you that way first. So I'm trying to isolate the variable in the middle. And in order to do that, I just think about, okay, I have 7 here. I'm going to subtract away 7 from each part. And this is the tricky thing because we're used to just doing it to two sides. Now I have this here and this here. So everywhere I see that, I've got to subtract away from that part. So subtract away 7 from here, here, and here, right? All three parts. So this will cancel. And 22 minus 7 is 15. So I have 15 is less than or equal to negative 5x, which is less than or equal to 47 minus 7 is 40. Now to isolate x in the middle, I have this negative 5. I'm going to divide each part by negative 5. Each part by negative 5. Each part by negative 5. Now, remember, when I divide by a negative, I've got to flip. And I've got two signs here. I've got to flip both of them. So this is going to flip this way, and this is going to flip this way as well. So 15 divided by negative 5 is negative 3. Negative 5 divided by negative 5 is 1, so this is just x. 40 divided by negative 5 is negative 8. Now I'm going to rewrite this. I want my smallest number on the left. So I'm going to put negative 8, and it's less than or equal to x, so I'm going to put less than or equal to x. And then I'm going to put x is less than or equal to negative 3. So less than or equal to negative 3. So now this runs in the order of the number line. And that's my solution. X is greater than or equal to negative 8. And it's also less than or equal to negative 3. If I find negative 8 on the number line, that's right here, I would put a bracket there because negative 8 is included. So that's the smallest value that x can take on. Negative 3 is the largest value that x can take on. So I'd put my bracket there. And shade everything in between, right? So I'm saying that x can be negative 8 and larger up to and including negative 3. Anywhere in those values would work. If I picked negative 5. Well, negative 5 is larger than negative 8 and it's smaller than negative 3. So that works. If I picked something outside of this range in the non-solution region, let's say 0, plug that in. 0 is larger than negative 8, but it's not smaller than negative 3. So that doesn't work. Right? So it's got to be something in this range of values. Now for my interval notation, I would put negative 8 as the smallest possible value, and I'd use a bracket there, right? Because negative 8 is included. And then I'd put negative 3 as my largest possible value, and then a bracket next to it again because negative 3 is included. All right, so let's look at one more problem. So we have that negative 5 minus 12x is greater than or equal to negative 5 and less than 127. So my goal is to isolate the variable x in the middle here. So I'm going to add 5 to each part. Remember, you got to do it to each part. So that's going to cancel and be 0. Make sure you write 0 there. You don't have anything else over there. So this is less than or equal to. And then this is going to cancel. I'll just have negative 12x in the middle. And then is less than, we have 127 plus 5, that's 132. And now I'm going to divide each part by negative 12. Again, because I'm dividing by a negative, I've got to flip all the signs. Very important. So this will be a greater than or equal to. This will be a greater than. And so 0 divided by negative 12 is 0. This cancels, and I'll have 1 times x, or just x. And then 132 divided by negative 12 is negative 11. So I'm going to rewrite this in the order of the number line. So x is greater than negative 11. So I'm going to put negative 11 here, and x is greater than that. And x is less than or equal to 0. So less than or equal to 0. So x is greater than negative 11, and x is less than or equal to 0. So in interval notation, my smallest value, I'm going to put negative 11, and I'm going to put a parenthesis next to it. I have a strict inequality there. X has to be strictly greater than negative 11, but up to and including 0. So my largest value is 0, and that's a non-strict inequality, so I'm going to use a bracket. So that's my interval notation, and then graphically, I'm going to find negative 11, and I'm going to put a parenthesis there. I'm going to find 0, and I'm going to put a bracket there. And then my solution region would be anything in between. Now 0 is included, remember, because I have a bracket. So it could be 0 or anything less up to but not including negative 11.